Hi friends, this is Dr. Pati. So let's solve one more problem on velocity acceleration analysis. Let's start. Now this is the given problem. The crank OA rotates at 210 rpm clockwise. Direction is given clockwise, isn't it? And you have to find acceleration of slider D and angular acceleration of link C. Okay, the step number one is to draw the space diagram, isn't it? And step number two is to find velocity of A with respect to O. You know V is omega r, which is equals to 2 pi n upon 60. This is omega into r. So by this way we can get the value of velocity of A with respect to O is 2 meter per second. Now, to draw the velocity diagram, we have to take some scale. I have taken 0.5 meter per second, so that I will get a first vector length around 4 point something, isn't it? So, first of all, draw the space diagram. So, this is the space diagram. You have to take some scale, and the scale is 1 centimeter is equals to 100 mm. Okay. Similarly, to draw velocity diagram, you have taken scale 1 centimeter is 0.5 meter per second. Now, step number one is to find the fixed point in the space diagram. This is first fixed point O. This is second fixed point Q. And there is one more fixed point G, third one, isn't it? Now, looking to the figure, given figure, you have to redraw this space diagram with some scale. Okay, and I hope you can do it. Now, coming to velocity diagram, as you know, there are three fixed points 1, 2, and 3. That is O, Q, and G. Take these 3 points at a single place. Now, coming to the crank, this OA is a crank, isn't it? It rotates clockwise. And when it rotates clockwise, you know, I have written here, what you know? You know velocity vector of all the links is always perpendicular to the link, isn't it? So you know this is velocity of A with respect to O is always perpendicular to the link AO, isn't it? So what it means, you have to draw a line perpendicular to AO in velocity diagram. That line which is perpendicular to AO represents some magnitude of velocity, and this arrow which is in the direction of the rotation gives you the direction to draw the vector. Okay, by knowing magnitude and direction you can represent velocity on a paper. You know this, isn't it? So let's draw first vector. So this is first vector. You will get point A here. Now, velocity of B, where is B? So this is B. Velocity of B with respect to A will be perpendicular to the link. So I can write here VB A. What it means, friends, you have to draw a vector perpendicular to this AB. But where to draw this? In the velocity diagram here, not in the space diagram. In the velocity diagram, you have to draw it a vector perpendicular to AB. Let's draw. So this is a vector I have drawn perpendicular to AB. Now, velocity of B with respect to Q is again perpendicular to this BQ. So this is VBQ. Friends, you have to draw a vector perpendicular to BQ here. And for that, Q is a fixed point, you know. So this is a Q fixed point. From this point, draw a line perpendicular to BQ. So let's draw. Now, you know, this point B is on link QC. This is point C. This is point Q. In between, you have point B. Now, once you get this vector, so draw. So I have drawn this vector, isn't it? And this vector, they both intersect here. So this is point B. Now once you get the point B, now I want to look at point C. And that can be located by means of ratio of distance. So everyone know ratio of distance? How to take that ratio? QB by QC. So this is from space diagram. QB by QC is equals to, from velocity diagram, QB, small qb by small qc. So I know qb, I know qc, I know this small qb also here. So I can get this qc. So get this point qc and you will get a point c somewhere here. Locate it. Okay. Now once you get this point c, now velocity of d, we need to find velocity of d with respect to c is again perpendicular to this link. So this is VDC. So friends, you have to draw this line perpendicular to DC from point C here. So let's draw. Finally, you know this slider D slides horizontally, isn't it? Horizontally means through fixed point 3, that is G. So this is G. Draw a line parallel to the direction of sliding. So this is the line of sliding. So you have to draw a line parallel to the direction of sliding. So let us draw. Here you get point D. So this way you have to draw a velocity diagram. Okay, I hope you understood this. Now let's move to next acceleration diagram. For that you have to find all this. You know this, how to find. Now we will draw acceleration diagram. For that I have taken here the required value of centripetal component of acceleration Fc, which I have already calculated in the last previous slide. But now remember, the scale I have taken is 2.5 meter per second square. This is the scale I have taken for acceleration diagram. Again friends, acceleration diagram is also drawn with reference to space diagram. So space diagram should be there, which you already drawn, isn't it? So this is space diagram you have with you. Now, one of our friend told me that, sir, you write how you say. Friends, now, acceleration of A with respect to O. So when you want to draw acceleration of A with respect to O, you first of all have to locate fixed point. There are 3 fixed points, 1, 2, and 3. So first of all you have to locate 3 fixed points O, Q, and G. The way you have located in velocity diagram, the same way you have to locate in acceleration diagram also. So this is the point. Now you would have wondering why it is so at corner. You already know. When I say acceleration of A, I will write here. Acceleration of A with respect to O. When we say so, we draw this arrow. We'll have 2 components of acceleration. One is Fc and second one is Ft. You know this, isn't it? Now this Fc and Ft, you know magnitude of this Fc, but you don't know magnitude of Ft. So but we know direction, isn't it? Regarding this centripetal component of acceleration, you know magnitude and direction also, isn't it? And the direction is what? It is parallel to the link. And Ft we don't know magnitude, but we know direction, perpendicular to the link. So you remember this, and you have to write like this. Okay. So I will write here Fc parallel. There is no Ft component, isn't it? So it will be 0. It will not be there, so it will be 0. So let us draw the first component Fc. It is in this direction, isn't it? And that's why this is O and Q. That's why I have located this O and Q on right side, because I want to draw a vector here in this direction. Okay, let's draw. With the scale 2.25, you divide this 48.4 by 2.5, you will get some centimeter, isn't it? You draw that much of line. Okay, draw this. So friends, you will get a point here. This is what? A dash. Okay, now coming to the point B, you say acceleration of B with respect to A. Acceleration of B with respect to A will have two components, Fc and Eft. You know magnitude and direction of Fc. So here it is 5.55. Now how that vector will be? It will be like this. Acceleration of B with respect to A is acting in the direction Fc, and Ft will act perpendicular to this link, isn't it? So very simple. Now you have to draw this Fc in this direction from A or B, which is known. A is known. So draw this. So you get this point. That is B1. And then you draw a perpendicular vector Ft. We don't know its magnitude. Simply draw and leave it. Now, one more point. Acceleration of B, same. With respect to Q, we will have again two components, Fc and Ft. We know magnitude of Fc. We know direction. Do we know direction? Yes, we know direction. This is Fc acting towards center of rotation. And Ft also know direction, but I don't know magnitude. But you have to write like this. Now I can draw a line from B or Q, which is known. B is not known, but Q is known. So from the point Q, you have to draw a vector Fc in the direction. Let's draw. So this is Fc. And you get one more B1. Okay. And draw perpendicular. Now both these will intersect at some point. This is point B. I hope you followed this, isn't it? Once you get this point B, join QB and AB. Actually it is dash. Okay, very good. Now, once you get point B, I want to look at point C. And look, point C is, by taking ratio of distances, you can locate point C. So this is point C. Now friends, acceleration of D with respect to C will have two components of acceleration. This is Fc and perpendicular Eft, isn't it? So locate these also. Now this is D1 perpendicular Ft. Now since the slider slides horizontally, so draw a line parallel through OQ to get this point D. Now join C dash D dash. So this is D dash, this is C